Vignesh. It is not visible. I think my screen is hanging. 1 second. Okay. I think, yeah. So Vignesh gave 3 reading. Is that all the 3 readings are same or different?
Different.
Different. All the 3 readings are different. And let me highlight all his readings with the same color, right? So blue color. All his 3 readings are shown in blue color. But actually, how many songs I played? 3 different songs. Am I right?
Yes,
I played 3 different songs, but actually all the three songs had the duration of exactly 60 seconds. All the 3 songs had the duration of exactly 60 seconds. Only the songs are different, but duration wise, all are same. That means you measured the same part 3 times. I have made you to measure the same part 3 times without making you realize it. All of you understand what I did now? Vignesh measured 60 seconds 3 times. First time he gave me 60.2. Second time he gave me 59. Third time he gave me 60.34. Now, now the error committed by Vignesh is called the repeatability error. Actually, he should have given me three readings same. Why? Because all the 3 parts are same part only. All of you understand? The duration of the clips are set in such a way that all of them are 60 seconds. When you measure 60 seconds 3 times, whether you give exactly 60 seconds or not, that is different. But you should give me at least same reading. When you give exactly 60 seconds, then you will be accurate. When you give same reading all 3 times, then you will be precise. So the repeatability error of Vignesh is getting reflected in the first row. All of you understand?
Yes, sir.
Similarly, Mayank, the reading of Mayank, does it have repeatability error?
Yes.
So each one of you has an amount of repeatability error. So we have the responsibility to understand the quantum of repeatability error that as a team you are accumulating. The permissible error is only 10%. When you commit an error of more than 10%, your data is unworthy for any study. Isn't it? So this is the repeatability error for each appraiser is understood. Now consider all the appraisers. As far as the Vignesh is concerned, Vignesh gave me 3 reading. Now I want all of you to calculate your average. I want all of you to calculate your average. And Vignesh, what is your average? Can you tell me?
59.84.
Okay, 59.84. Same way, Mayank, what is your average? All of you calculate your average.
$59.99, Dilip.
Sir, you 60.21.
Who's, you tell me your name and say, otherwise, you have to be on video. Who is saying?
Mehul sir 60.21.
Okay, 60.21. Okay. Then Patel?
58.68.
58.68.
59.53.
Okay. Then Dilip?
59.99.
Clear. See here. Please note all of you. If all of you measure the same part, each one of you measured the part 3 times. But when I calculate the average, do you see the average also having some variation? If all of you measure in the same way, the average of your reading and average of everyone's reading should be same. Isn't it? If you measure in the same way, average should be the same. But average not same means It definitely represents the disagreement, the inconsistency between the appraiser. Whatever variation you are observing in the average is called the reproducibility error. There are two types of error all of you are committing. While measuring the three parts, you commit error within you. That is called what? Repeatability error. Then each one of you are not aligning with the team. You are not aligning with the team. I am seeing in the average. You are not aligning within yourself. I am seeing in your individual reading. Your individual reading will reflect the repeatability, and the variation in the average of the reading will reflect the reproducibility. So if you don't understand that these type of error will always happen. Can somebody tell me why this error happened? You all were given the best stopwatch, am I right? The Android stopwatch you all were given. And I explained the instruction. In spite of all our best effort, the error came. Can you tell me what is the reason?
On time and off time is different.
On time, off time is different. And some of you you got mingled with the song while making the
Human error.
human error. All of them, all combination. Some internet lag may be there. Am I right? So environment, operator, and the particular part you are measuring may also tempt you to do some error. For example, the last song. You could have measured it definitely with some error. So same way, some of you could have liked the Tamil song, some of you could have liked the Hindi song. So the part also can trouble you. So you can't easily figure out what is going wrong. You require a detailed investigation to calculate the error, but the repeatability and reproducibility both put together, the error should be only 10%. If you are not able to maintain the error within 10%, then according to a guideline, industry guideline called an organization called AIAG, Automotive Industry Action Group. According to them, when the error is more than 10%, your measurement system is unworthy. But 10 to 30% conditionally okay. 10 to 30% conditionally okay. Certain cases you can accept. But what are those certain cases? Probably you have to learn deeper. You can decide to join our green belt or a black belt training program. I will tell you when you can accept an error of 10 to 30%. But more than 30%, 200%, your data, you must throw it into the dustbin. Don't use the measurement system. Don't collect the data. You can't succeed in your project when the error is more than 30%. But preferred value is less than 10%. All right. So this is the equation. The measurement error can be calculated. You don't worry about the calculation part right now because that requires some deeper understanding on the calculation. We have to spend at least 1 hour on the same topic, and then only you will understand. The sigma repeatability you are seeing. Sigma repeatability is nothing but the standard deviation of the standard deviation for the repeatability error. Standard deviation for the repeatability error is sigma repeatability. Similarly, the average you have seen, so many averages I have shown you. For all the average data, if you calculate the standard deviation, that will be the sigma of the reproducibility.
अरे ले जाओ बैंड को, ऐसा तो गणे लगाए हैं बैंड को अंदर होगा, बना दे मेहुल भाई, बना देंगे.
Abhishek is already a black belt. He doesn't want to listen to us, right? So sigma of repeatability is there, sigma reproducibility is there. You have to combine both the error. If you combine both the error, then you get the sigma of the error. Sigma of the error means it takes into account repeatability, it takes into account reproducibility. When you are adding sigma, you can't add just like that. When it is 2 and 3, what is 2 plus 3? 5. But standard deviation, you should not add like that. Standard deviation, you have to square, and then you have to add, and then only you must, and then you have to take the square root. That is how you can combine two standard deviation. Your normal algebra will not work, and so sigma of the error is calculated. Once sigma of the error is calculated, What is your goal? When your people are measuring data, collecting the data during your project, every time they measure, they will commit an error. Now you could have understood. Every time your people measure, they will collect some amount of error. I am interested in knowing the total amount of error your team may commit during the project. Your project is 3 to 6 months. Within 3 to 6 months, so many times they will collect the data. Am I right? So many times they will collect the data. The total error your team will commit can be estimated by multiplying the sigma with the 6. Because 3 sigma on the right side, 3 sigma on the left side will contribute to 99.73% of the data, isn't it? If you collect 10,000 data in your project, 99.73% of the 10,000 data will be accounted when you go up to 3 sigma on the right side, 3 sigma on the left side. Same understanding works here. So multiply the sigma of the error with the 6, you will get an idea of the total precision error. Total precision error, because precision is a combination of repeatability and reproducibility. Repeatability and reproducibility put together, we call it as precision error. And now I said 10%. When I said 10%, denominator is required. For example, in your yellow belt exam, maybe yellow belt exam, which you are going to write tomorrow, the pass mark is 60%. When I say 60%, what is the denominator? Denominator is 100. Out of 100, you must answer 60 questions correctly, isn't it? Right? So 60% means 60 out of 100. Same way, when I say 10%, the denominator need to be understood. So the denominator is nothing but tolerance. What is tolerance? We already studied, right? USL minus LSL. USL minus LSL is the tolerance. What is numerator? Numerator is 6 into sigma of the error. 6 into sigma of the error is called precision. Denominator is USL minus LSL. That is called tolerance. So this ratio is called precision tolerance ratio. What is this ratio? Precision tolerance ratio. This precision tolerance ratio is specifically called as GAGE R&R. GAGE R&R means what? Precision tolerance ratio. When you multiply by 100, you will get it in terms of percentage. When this precision tolerance ratio is less than 10%, your measurement system is good. When this precision tolerance ratio is 10 to 30%, then it is conditionally acceptable. When it is more than 30%, I will better avoid collecting the data. If at all data has to be collected, I will improve the measurement system and then only I will collect the data, because I am very clear that when I continue collecting the data with the existing measurement system, I will definitely go in a wrong direction. So I will not do that. All of you understand what is GAGE R&R now? There are two things you have understood. One is accuracy, another one is precision. And in accuracy, there are 3 types of error. What are the error? Bias, linearity, stability. In precision, you have 2 types of error: repeatability, reproducibility. And repeatability and reproducibility combinedly called GAGE R&R, right? So when you have issue with the GAGE R&R, understanding the root of the problem is not that easier. With the data collected during the GAGE study, you need to plot 6 graphs. You see here, first graph is bar chart, second graph is control chart, third graph is another control chart, fourth graph is dot plot, fifth graph is box plot, sixth graph is again dot plot. By referring to the graphs one by one, you can pinpointedly understand whether who has made a lot of error, whether it is Joy making lot of error, or Vignesh making lot of error, or is it Patel making lot of error. I can pinpointedly find out, but I have to plot all these graphs, right? So which you will be learning in the main training program. And also with the same numbers, I can calculate the GAGE R&R value. What is the GAGE R&R value here? Can you read out the number? How much it is? 4.27. 4.27 means less than 10%. So when it is less than 10%, okay, your measurement system is good and you can trust the data, you can believe the data and you can proceed. So the main objective of the measure phase is validating the measurement system. After validating the measurement system only, you must calculate the sigma level, you must calculate the baseline performance. Basic statistics will help in summarizing the data. Yeah, because the statistics is always required. See here, when I conduct the gauge study also, I used the average. So always statistics will help you to summarize the data with the central value. Only with the central value, the average, we understood about the reproducibility. Only with the variation in the data, we understood the repeatability, right? And MSA terms, what we learned are bias, stability, linearity, resolution, and gauge R&R. What is required? Gauge R&R should be less than 10% of the tolerance. Less than 10% of the tolerance, we call it interest zone. And you can, in the denominator can be customer tolerance, denominator can be process tolerance, denominator can be study variation. Customer tolerance means USL minus LSL. Process tolerance means UCL minus LCL. Study variation means the highest value minus lowest value in your data, right? And when your data is continuous data, you must definitely conduct the gauge R&R study. You must definitely conduct the gauge R&R study. If your data is attribute data, then you must conduct a study called attribute agreement analysis. One is gauge R&R, which is for continuous. For discrete data or attribute data, your study must be attribute agreement analysis. In attribute agreement analysis, we calculate team accuracy. All of us have to know, make the same conclusion. Correct, same conclusion only all of us have to make as a team. So that is called team accuracy. If the team accuracy is more than 90%, your measurement system is sound. 70 to 90% conditionally okay. But less than 70%, the team has to be trained on how to measure. For example, in TV channel program and all, you see some 3 judges will be there always. Each judge will give mark, isn't it? All the 3 judge should give, more or less similar mark. If one judge is, giving completely a different mark, then decision will go wrong. So that is what we are trying to understand here. Is that measure phase clear? All of you? Any questions so far? Come on, any questions?